Now we discuss about nodal analysis problem. First problem, calculate the voltage across each resistor. Is a chip-chop circuit. So first the circuit is arranged by using normal circuit. Here 6 volt is series with 2 ohm, then parallel with 2 ampere current source, and 3 ohm resistance is connected in series with 9 volt voltage source, and 4 ohm resistance is connected in series with 16 volt voltage source. So here is a normal circuit. But the nodal analysis is only depending upon the current source. So each and every voltage source must be converted into current source. So here the 6 volt is converted into current source. Similarly 9 and 16 volt is also converted into current source. So by using current Ohm's law, I is equal to V by R. So here V is 6, R is 2, so 6 divided by 2, 3 ampere. So each and every voltage source must be converted into current source 3 ampere, 2 ampere and 3 ampere. Away from the node is negative, then towards the node is positive. Here there is only one node because there is no resistance in the upper side of the circuit. Here is a reference node, so here there is no resistance, so only one node is available. So by using Ohm's law, P is equal to IR, so I is equal to V by R. So 1 by R into V into I. So here first term is 1 by R, reciprocal of resistance. That is first node, there is a resistance towards the first node is equal to 1 by 2 plus 1 by 3 plus 1 by 4 because only one node. So here 1 by 2, 1 by 3 plus 1 by 4 is into next term V is equal to the current source towards the positive. So here 3 plus 2 then plus 4 then minus 3. So is equal to 6 ampere. So here the total value of the circuit is, that is V is equal to 6 divided by 1.08. So V is equal to 5.55 volt. So the voltage across each resistance is 5.5 because is only one node. So voltage across each resistance is 5.5 volt, but the power is entirely different because the power is depending upon the voltage and current. Here voltage is same 5.55, but the current resistance is different. For example, the power across 2 ohm resistance is equal to I square R or VI. So here 2 into 5.5, 10 something. Similarly, the power across 3 ohm is 3 into 5.5 volt. Then power across 4 ohm is equal to 4 into 5.5 volt. So the second problem, similarly, but here current source and the voltage source is available. So you here calculate the voltage across each resistance by using nodal analysis. Is a complicated complicated circuit, but it is a simple circuit. So here there is no change because it is a current source. Here only voltage source. The voltage source must be converted into current source. Here known value is 18 volt. So voltage is 18, resistance is 6. So current is equal to 3 ampere. Here towards the node. So here how many node means there is two nodes, that is V1 and V2. There are two nodes because only one resistance is in between the first and second. So here V1 and V2. So here R11, 1 by R11 means the reciprocal towards the node V1, it is 1 by 4 plus 1 by 5. Similarly, one in between the 1 and 2 is 5. So minus 1 by 5. 2 1 minus 1 by 5. 2 2 means the total resistance towards the node, it is 1 by 6 plus 1 by 5. So is equal to 0.45 minus 0.2 minus 0.2, 0.366. So next term is V, that is V1, unknown value V1 and V2 because there is no two node V1 and V2. There current is, first current is 2 ampere and 3 ampere. So delta is calculated by using matrix method. Delta is equal to 0.125. Delta 1 is a replace the first column of the circuit. So here 3 into 2. So now we calculate the value of delta 1, 1.48. We know that the V1 is equal to, by using mesh method, I1 is equal to delta 1 divided by delta. Similarly, V1 is equal to nodal analysis, V1 is equal to delta 1 divided by delta. So V1 is equal to delta 1 divided by delta. Already we calculated the value of 1.48 delta 1. Then delta is a 0.125. So V1 is equal to 11.84 volt. Then delta 2 means replace the second column of the matrix. So 0.45 minus 0.232. So here delta 2 value is 1.5. So V2 is equal to delta 2 divided by delta. Already we calculated the value of delta 2 is equal to 1.5. Then delta is equal to 0.125. So here V2 is equal to 12 volt. So V1 means V2 means here the voltage across 4 ohm resistance is equal to V1. That is V1 is already calculated 11.84. In voltage across 6 ohm is V2. V2 is equal to 12. But in the case of voltage across 5 ohm is equal to V1 minus V2. That is 11.84 minus 12 is equal to point something. So similarly, we are also calculating the value of power. Power across 4 ohm is equal to, that is I into V into I. Here V is 11.84. Then R is equal to 4. So here already calculate the value of power is I square R, V square divided by R VA. Similarly, we calculate the power across 6 ohm is VA or V square divided by R or I square divided by R. Similarly, we are calculating the power across 5 ohm, it is V square divided by R, I square R divided by R VA. Thank you.